Hello and welcome to the Daily Space for today, Halloween 2019. Halloween is one of our favorite holidays, and it is one that even the universe gets involved in putting on some pretty creepy costumes. But that's how our show is going to end. It's not exactly where it's going to begin. Where it's going to begin, actually, is with the beginning of the universe. One of the things that we've really struggled to understand over the years is, where do stars come from? And do they, well, do they act in ways that we understand? As we've been trying to figure this out, we've been waiting eagerly for the James Webb Space Telescope to launch, and this was one of those things that it was supposed to figure out. Well, as JWST has been delayed over and over, astronomers have gotten impatient and found ways to do JWST's planned science without JWST. Today, a team led by Eduardo Benadas of the Max Planck Institute for Astrophysics has published results showing that, well, within 850 million years after the Big Bang, stars had already had a chance to live and to die. This team studied quasar P183 plus 05 and found in its light traces of an intervening cloud of gas that existed near this, well, very distant object. As quasar light passed through the distant cloud of atoms, well, those atoms absorbed out quasar light, creating dark bands that could be used to study the composition of the cloud. Now, when I say this quasar and cloud are distant, I mean distant. The studied light was emitted just 850 million years after the Big Bang. This early in the universe is poorly understood, and we're still trying to sort out how the first generation of stars formed, lived, and died. And in looking at this distant gas cloud, this team hoped to place limits on the first generation of stars. In general, the shortest lived and largest stars take 1 billion years to form, live, and die. But the first generation of stars, well, they may not have behaved like regular stars at all. In looking at this cloud that was less than 1 billion years old, the research team found traces of carbon, oxygen, iron, and magnesium, elements that could only be formed in stars. More importantly, the abundances of these elements weren't unlike what we see in modern star-forming regions. The base material of our universe was nothing more than hydrogen, helium, and minor amounts of lithium and beryllium. Stars, with their nuclear-powered cores, stars generate everything else that we see. And after the first generation of stars, those heavy elements changed how stars were able to form. While the amount of the heavier elements in this cloud was 800 times less than what we see in the sun, this small an amount still means that first generation of stars, as well as an additional generation, a second generation, was able to enrich it, if only slightly. According to the press release, the fact that this gas cloud in the very early universe already contains metals with modern chemical abundances poses key challenges for the formation of the first generation of stars. Specifically, this research raises questions of just how brief was the life of those first stars? And just how massive and short-lived was that second? What this research does tell us is stars pretty much formed immediately after the formation of the cosmic microwave background. And those first stars may be even harder to observe than we had previously thought. This points to, well, difficulties that James Webb Space Telescope, well, we'll have to solve someday. But for now, this is just pretty amazing science. Today is really a day of solving mysteries. From the beginning of stars, we now move to what should have been the end of a couple of planets. The TESS mission has now studied two evolved stars that are in close proximity to planets, or rather, I should say, the planets are in close proximity to those stars. And those planets should have been consumed when the stars expanded out during their red giant phase. Since we can now, see those planets, clearly they weren't eaten by the stars. Using TESS's extraordinarily precise brightness measurements, scientists were able to look at these stars and detect the slight oscillations that exist in these stellar atmospheres. This is a process called astroseismology. And they used these measurements to in turn precisely measure the stars' sizes and masses. Together, all of these measurements made accurate models of these stars possible. And from these models, the team has learned that it is quite likely that these planets started much farther out, but were then drawn in through tidal interactions. The same process is currently taking part with Mars' moon Phobos that is gradually moving toward its planet. This research highlights yet another way that stars can move around their planets and makes it clear that the solar system we see today is just a snapshot of, this moment in time. Solar systems, extrasolar systems, all of these systems of planets and stars are constantly changing environments. And where we see worlds today is not where we may see them tomorrow. And this research is further, strengthened by our next story. It turns out that understanding solar systems is really one of the hardest things we can do. We don't just struggle to figure out how planets end up snuggled up against old stars. We also struggle to figure out, how they end up snuggled up against young stars. One of the most perplexing things that was discovered early in the study of exoplanets was the existence of giant planets right next to their stars, and also giant planets in highly elliptical orbits that it seems like their mass would make it really hard to get them into. Well, it turns out that it may be all of these weirdnesses are just due to collisions. There have been a lot of explanations put forward. I'm not saying this is the final solution. I'm saying this is a cool solution we need to pay attention to. In a new paper in the Astrophysical Journals letter that has first author Renata Frlik, a new idea is put forward based on a series of computer models. This team took solar systems that consisted of 10 different planets, and they varied the amount of mass that was able to go into the formation of the solar system, and they varied the sizes of the individual planets. And across hundreds and hundreds of different models that they each allowed to evolve for 20,000 years, they were able to see, collisions that put planets into the orbits we actually see today. And the reason that we haven't seen these kinds of model results before is this research did something that's generally not done. In trying to imagine how solar systems form, we generally start from the premise that, solar systems should only have one truly massive planet like Jupiter, and everything else should be smaller. And that conceit, based on how our solar system appears, doesn't actually match what we see. There are plenty of solar systems out there that we're now finding have multiple gas giants. And by allowing her model to match the universe, she was able to replicate systems with these high eccentricity gas giants that plunge in next to their star before racing out to greater distances. So it turns out that, well, we need to actually base our models on the way the universe actually appears and not how we expect it to appear. And I don't know why that hasn't happened earlier. But sometimes, even for scientists, it's hard to move beyond what we've been taught should be true. And finally, since it's Halloween, we have different spacecraft working to outdo each other with ghastly pictures. In this first image coming to us from the Hubble Space Telescope, we have an image of two galaxies in the process of merging. This is the ARP-Midori system. It's located 704 million light years from Earth. And the way the collision is lined up, it just happens to look like a crystal skull in the cosmos that Indiana Jones hasn't quite scooped up yet. But Spitzer is not one to be outdone. And so Spitzer went out and found us a hot stellar nebula. There's an O star in the center of all that gas. And, well, they decided it looks like a jack-o'-lantern. Exactly which of these images wins this year's cosmic, costume contest? I leave that up to you. For now, however, I am going to answer your questions. So please type them in and remember to put that purple circle with a brighter, or rather a darker purple star inside of it in front of your questions. While you type them in, I'm going to remind you that the Daily Space comes to you most Mondays through Fridays at 1 p.m. Eastern, that is 10 a.m. Pacific, 6 p.m. London time. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are brought to you by you. I hear those bits coming in, and thank you so very much. We are made possible through your generous contributions, through your bits, your subs, and your donations. One of the best ways you can support us is over on patreon.com/CosmoQuestX. We wouldn't be here if it was not for the immeasurable work of Susie Murph, who called me on the phone when I launched this episode with no audio and told me I launched this episode with no audio. Susie is the one who, herds cats, keeps us going, and makes sure we don't make too many mistakes. And it's because of you that we are able to pay Susie and Annie. So thank you, thank you, thank you. And now I will look to see what all has been typed into the questions. Thank you so much, Ed Thompson, for the bits. I do have an Eddie down here with me. Let me grab the treat bag because we all know what bits means. Hi, I see you sitting pretty. You want this? You do. You do. All the way up. Hi. It's harder to get him to be cute in this particular alignment. Hi, I see you. I see you. Okay, so now to see what questions you have to ask. Scrolling. I'm going to go all the way back up to the top. Oh man, apparently I have been muted 113 times. Wow, sparkly but muted. I like that comment, Trekker Crev. Thank you, Nebula Cluster, for the compliments on the costume. aiming for a Macbeth style witch. So there will be brewing in cauldrons later today. For those of you who don't know, over on my personal stream, Star Strider with a Y, I do narration, and tonight, in celebration of Halloween, I will be reading many a ghostly tale. You can get a complete list of what I plan to read over on patreon.com/starstrider in a public post. Yeah, I totally couldn't see. I'm so sorry, everyone. Ah, I like the way Enigma put, you tried Nightbot. Your service has been noted. Um, you guys are so patient with me. So very patient. Broken Symmetry. I will totally be wearing my Doc Marten boots with the outfit. Once I figure out where I put them to prevent the dogs from eating them, I moved them the other day. So currently I'm wearing my slippers, but they're wool slippers. So does that count? Um, okay. I did indeed, Veronica, say, how am I muted? It's true. It's true. I was very confused. Okay. Yeah, I got it working. Um, yeah, the telescope that shall not be named. Population 3 were James Dean stars. It's true. It's true. Yeah, Dr. Goth, I support that. I support that. Not many questions today. Best stream out there, even when muted. Oh, man. So Henny asks, could interstellar objects act as seeds for planet formation if they were captured? Yes, and there's actually some computer models out there that think that seeds of debris from old solar systems could be at the core of planets forming in new solar systems. So the universe just recycles over and over again all through history. That's the way it works. Other questions? Oh, Mythtown had one but forgot it. That's okay. That happens. It's all right. So I hope all of you have fabulous Halloween plans. We are all waiting here in Southern Illinois to find out if Halloween was canceled. It's gross out there today. I actually got up and it was snowing. Not snowing the way those of you up in like Montana have experienced, but snowing. And it seems to have all stopped and melted, but it's just wet and cold and gross out there today. Normally, we have a Halloween parade that should be going tonight, but I don't know if it's going to happen given the weather. They already moved trick-or-treating from last night when it was pouring rain and only 40 degrees to tomorrow night when it's supposed to simply be 40 degrees. We'll see. We'll see. More nights of Halloween, I guess. So I hope to see some of you this evening over on the Halloween Star Strider stream. And if not, I will see you tomorrow when we return again for the daily space. As always, we run at 10 a.m. Pacific, 1 p.m. Eastern. That is 6 p.m. London time. Tomorrow, being a Friday, we will also have Astronomy Cast following roughly an hour and a half after the daily space, and we will be simulcasting that right here on Twitch. So go out and oh, Annie, can you start the credits? I can't reach the button to start the credits. I'm a terrible, terrible human being some days. So thank you all for being here. We will find someone to raid, or Annie can just raid someone because she's out there and she's amazing. I will be back tomorrow. And as always, I'm going to go record. Thank you for the bits. The dog wants treats. Yes, dog, you can have treats. Come on up. Here you go. Good boy. Good boy. Good boy. Get down. We are a product of the Planetary Science Institute, a 501c3 nonprofit, and we are produced by Susie Murph. My co-host is Annie Wilson, who will be bringing you rocket things and stuff as possible. We are still trying to figure out what's going on with the Japanese mission today. Anyways, wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you on the other side. Bye-bye.